So now for problem number 3, it's the same figure, but now it says, what's the work done by F sub 2 as the object moves up the inclined plane? Now this one's a different question. Remember, and I kind of skipped over this, it's the work is equal to the force parallel to the displacement. And so if we look at F sub 2, if we look at that, you'll see that it's not quite parallel. So we have to break this up into component vectors. In other words, it's going to have like a vertical displacement and a horizontal displacement. And so and I'm going to treat it this way, like this is my y-axis and this is my x-axis. And so this is like an angle that goes through here, and I'm trying to find this portion of it. I'm trying to find the force in this direction. So to get this resultant vector, I go down, and then I go over, and that makes a right angle triangle with the angle of 30 degrees. So what I'm really looking for, if this is my angle theta, which is 30 degrees, then this is the opposite side of the triangle, and this is the adjacent side of the triangle. Which trig function deals with adjacent? Tangent does, but what's a better one? Cosine. The reason I say that is because h is the hypotenuse, and guess what? I know what the magnitude of the hypotenuse is. This is f sub 2 is equal to 40. So it's cosine. So cosine of theta is equal to the adjacent over the hypotenuse. If I multiply both sides by the hypotenuse, then I get h cosine of theta is equal to the adjacent. That's what I'm looking for. So I'm going to say 40 cosine of 30. Somebody do that on your calculator real quick. Make sure that you're in degree mode. Okay, I'll fire up my calculator too. And so we're doing all this work to find the force that's parallel. This is parallel, okay, to the displacement. Now the displacement's the same. It's still just 0.6 meters. But I need to figure out that result. I'm going to break down that resultant vector. I'm treating f sub 2 like a resultant vector, and I'm going to break it down into its components. And so I want to say 40 times cosine of 30, and I'm pretty sure I'm in radian mode, so I'm going to check that real quick. Yep, we almost always use radians in AP Calc. All right, so now I'm in degree mode. Boom, I get this number. So that is the resultant vector, or the component of the resultant vector. And so the magnitude of the force that's parallel to the displacement is 34.64 newtons. Okay, so now what that means is my work is equal to this 34.64 stuff, and I just need to multiply that by the 0.6 meters. Any questions before we do this? I feel like I'm going kind of fast. Does that make sense to you guys, what we're doing? And yes?
I didn't do any of that. I got the right answer.
Well, let's see. Let's see. So now if I multiply this out by 0.6, whoops. So that's 20.7. What was the right answer?
It's right.
Wait,
If you round it, it's 20.8. What was it? It was 20.7 something? Yeah, 27.8 or whatever. Now,
3?
any questions?